Okay. So, sorry that the first half wasn't recorded. I feel so bad about that, but hopefully the second half will be good as well. So, when we're talking about boiling point, we know that alcohols have a higher boiling point than ethers do. And we know that boiling point increases, so we have a higher boiling point when we are less branched. So, less branched equals higher BP. And we also know that we have more carbons equals a higher BP. So for number 80, we're looking for which of these has the lowest boiling point. And we have just a straight carbon chain for A. We have an ether for B. We have an alcohol for C. D is also an alcohol, but it has a little bit more branching, so that's the difference. And then in E, we actually have 2 alcohols. So which of these do you think has the lowest boiling point? A. Yes, I agree. The biggest difference is that B through E all have oxygens. A does not. So we know that that is going to be the lowest. If A was not here, so if it was only B through E, which one of those would have the lowest boiling point? B. Perfect. Okay, awesome. So E would actually have the highest boiling point because the more alcohols you have, the higher your boiling point will be. So for the previous question, do you mean like this one, or do you mean like the one we just did here? That one? Yes, we can. I just want to do the other boiling point question real quick, and then we can move on. So for the highest boiling point, we have, again, a straight chain for the carbon. We have 2 alcohols here, or excuse me, we have 3 alcohols, 1 alcohol, and 2 alcohols. So which one of these do you think will have the highest boiling point? I would agree that B is correct, yes. And the reason is when we are only comparing, well, first of all, we know that A has just a straight chain with nothing on it, so that one is obviously not it. For the rest of these, we're comparing all alcohols, so the one with the most alcohol will have the highest boiling point, correct. Sorry, I forgot what English was for a second. But to the person who requested boiling point, does this make a little bit more sense? Yes? Okay, awesome. Any questions about this before I move on? You are very welcome. I'm scrolling, but feel free to ask more questions if you have it. Okay, so essentially, number 87 is asking which of the following is not true of ethers, and you will have a similar question to this. I don't think E will be there because we didn't really learn that, but we know that ethers are unreactive towards strong acids, are unreactive to everything besides strong acids, because we know that ethers are only cleaved in acid, besides epoxides. We also know that ethers have a lower boiling point than alcohols and a higher solubility than alcohols. And we also know that ethers are going to be cleaved in strong acids. That's pretty much the same as A. So for that reason, we know that C is not true because C says that it has a lower water solubility. Yeah, I don't think E would be there because he didn't really teach you that. We never really learned about that. But just kind of keep an eye on it. Just remember that you saw this here just in case. if that makes sense. And yes, we can definitely do 91 and pretend you didn't see the answer. So we are going, actually, we're not going to do 91. Well, yeah, I don't want to do 91 just because that's kind of an Orgo 1 reaction. I don't want to spend too much time on it. We will have like different syntheses kind of reactions there, but I don't think he's going to ask about chapter 1 reactions. But you know what, just in case. So we did kind of cover this. So what reaction do these reagents undergo? It's an Orgo 1 reaction. Yes, so hydroboration. And so hydroboration in like Orgo 1 when we learned about it has to sorry. I lost my train of thought. We need a double bond to do hydroboration, right? So in this first step, we are essentially going to perform an elimination. So we're going to kick this off, form an elimination, and then we're going to do a hydroboration. And so when we have a hydroboration, what was the key thing that we had to remember about that? It has to do with like Markovnikov versus anti. Yes, cool. So it's anti-Mark. So does that correspond, like, does that make sense with what answer we've gotten here? Yes, it does, because if we were to form a double bond here and perform an elimination, and then perform some kind of hydration reaction where we add an OH, the OH would be preferable to be in the middle here, not on the least substituted side. So if we have a primary alcohol, that means we had to do a hydroboration and have an anti-Mark addition. So for that reason, B is going to be the correct answer. I feel like I had a stroke while I was explaining that, so please let me know if it didn't make sense, and I will go over it again. But does it sort of kind of make sense? Yes? Okay. Good enough for me. So last one we'll do is this one, and then we can move on to chapter 18. So SO2Cl3, we know that's going to be either mesylate or tosylate. So when it has this CH3, is it going to be mesylate or tosylate? Mesylate, exactly. I mean, it says it for you here, but I was hoping you guys wouldn't notice that. So in this first step, we are going to keep stereochemistry. In this next step, we're going to do an SN2 reaction. And in an SN2 reaction, what happens to stereochemistry? Inversion. So we're going to flip. So we're looking for the answer that replaced essentially the OH with an iodine, and we want to flip the stereochemistry at that center. So which of these answers do you guys think is correct? So yes, it can't be this one because we replaced the iodine here. Can't be this one because that's gross. So it's between 1 and 2. And 2 is the one that flipped the stereochemistry, so I believe B is correct, and you guys would be right. Ta-da! All right, so are we happy with chapter 11? Is there anything you guys want to cover before we move on and do chapter 18 problems? I'm gonna stop sharing my screen for just 1 second, and I'm going to go open up the review packet that he posted because I forgot to save that last time. Sorry I keep rubbing my eyes, I'm just so tired. Did he email that to you guys, or was it like an actual module that he posted? On Canvas? Oh wait, was it part of the video or was it just a separate PowerPoint? PowerPoint? RIP, why can't I find it? I'm gonna find it on my computer and just send it to myself because for some reason Canvas isn't doing its thing. But in the meantime, if you guys have any other questions or anything, just like tell me and I'll like talk about it while I try to open this up. And someone said I'm so excited to sleep after this week. I feel that so much. I'm like unreasonably tired right now. Like there's no reason for me to be this tired. That would be awesome if you could just email it to me. Because it's just not popping up. And then someone had asked another question, so let me answer that while we open that up. Okay, wait, it finally opened up. We're good. It was just being silly for a moment. Okay, so which slide were you talking about? Slide 18. Okay. All right, so let me just share my screen again. All right. So I'm assuming you mean this question? Okay. So all right. For some reason, it got rid of like the oxygens, but that's fine. So we are starting with a beta keto ester. We're doing a alkylation followed by a nucleophilic substitution, right? And then we are going to have a decarboxylation happening. So this will be called a what? Is it going to be malonic, acetoacetic, or so this is considered an acetoacetic ester, but not every, okay, so it's part of the acetoacetic ester synthesis, but it's not going to be an acetoacetic ester. And the reason for that is the acetoacetic ester looks like this. And it's very specific because this is an acetate and this is an acetic ester. So this specific molecule would be an acetoacetic ester. Anything else that has this general framework is going to be a beta ketoester. So since this one right here doesn't have just the acetate group here, this is going to be a beta ketoester and not an acetoacetic ester. Does that sort of kind of make more sense? So the short version would be, because of this big R group not being just a CH3, for that reason it's not considered an acetoacetic ester. Okay, good, I'm glad. And so then the second question is the conversion of A to B would be an alkylation, so C. And yes, so any beta ketoester can undergo an acetoacetic ester synthesis, but in order to be called an acetoacetic ester, it has to specifically look like this. I don't like the way they name this reaction because it just makes everything so confusing, but I hope that makes a little bit more sense. Essentially, that's just the name of the reaction. You're very, very welcome. Okay, I see a couple new people join, so I'm sending the attendance link. Please fill that out if you would like. All right, so for chapter 18, let's just erase all this garbage. So one of the most common questions that you're going to get for chapter 18, or in my opinion, like the easy freebie question, is something like this. So he could either ask you for the keto-enol tautomeric pair, or he could ask you for the two resonance structures of the enolate, or he could ask you both. So in this case, we know the keto-enol tautomeric pair has to look something like this, right? We have a double bond to the alpha carbon, and we go from a ketone to an alcohol. So which one of these answer choices represents that pair? Number 2, I agree. And so if he asked you for the the enolate resonance pair, we know that the enolate is going to look something like this. And the biggest difference between these two is that the tautomeric pair is a pair of tautomers. This is a pair of resonance structures. And someone please remind me what the difference between tautomers and resonance structures are. And you don't have to give me like the definition, just like in general, what's the difference? So yes, tautomers are constitutional isomers that interconvert in acid or base. So we're physically taking a hydrogen and moving it somewhere else. Whereas the resonance structures are just moving electrons. So we're not breaking or making any real bonds. We're just moving those pi electrons. Absolutely right. Perfect answer. Alrighty, so I'm going to give you one that looks, you know what? No, I have a better idea. Br2 and AOH. Okay. So if I gave you this, first of all, we have Br2. So what kind of reaction is this? Halogenation, yes, and it is base catalyzed. So we have a halogenation, base catalyzed, we have our excess, and we have an open carbon. So how many times are we going to halogenate this? I can't even trick you guys anymore. You catch on too fast. Okay, so someone said we're only going to do it one time, and why is that? We have base, we have excess, why aren't we going to do it 3 times? Yes, so out of these 2 alpha carbons, this one is going to be the most stable because it is the most substituted. And we only have 1 hydrogen there. So you are absolutely correct. The answer would be this. Perfect. So how about, I had another really, oh yes, here we go. All right. Actually, let's make it spicy. Let's do chlorine. Oh, so for the last one, someone asked, does it always need to say excess for multiple halogenations to occur? So not necessarily. This is the annoying thing. It should always say excess, right? But it doesn't have to. So if you're doing the haloform reaction, it should say excess, but it doesn't necessarily have to for you to do it. You just kind of have to assume that it will happen. Same thing with the Grignard reaction. So yeah, I hope that makes sense. All right. So someone remind me, what is LDA? It is a base, but why is it special? Because it's a bulky base. Exactly. And so the bulky base means that even though alpha 1 is the more stable way to go, we cannot steal that hydrogen because the base is too bulky. So instead, we're going to steal this hydrogen on alpha 2. Therefore, our product will look like, why did I make this so complicated for myself? Like this. And remind me, in this second step, when we attack the alkyl halide, what type of mechanism do we use? SN2, sweet. So I know these weren't technically practice problems, but Did I miss a bond? Let's see. 1, 2, 3, 4. Oh, yeah, I did. Thank you for pointing that out. So these weren't technically practice problems, but I've seen ones like this. I just didn't want to scroll through for a million years and not find it. So this is a good point. So multiple alkylations won't occur. The multiple halogenation thing is specific just to halogenations because halogens are so electronegative and so withdrawing. You're welcome. Okay, so we already did one similar to that. We did one similar to that. Okay. So BR2 and PBR3, what kind of reaction is this? It's the ugly, complicated name, so if you give me even like, dang, wow, and you spelled it right, 100 points to you. So this is the Volhard Zielinski reaction. And essentially, we have two different ways to do this reaction. We can either have H2O or have H2O be missing. In this case, H2O is missing. So all we can do is halogenate and replace OH with Br. So which of these answer choices shows a halogenation on the alpha carbon and turning the OH into a Br? Yes, I would agree with number 3 because we added this bromine and this bromine. If we had H2O, let's say, we would end up making this answer because we would turn that bromine back to an OH. Make sense-ish? Any questions, comments, concerns? It's like 1:49, so I don't want to go on to another practice problem because I know it's a busy day today. So I will stay on for a couple more minutes. If you guys have any questions, comments, concerns about the exam, about specific topics, anything like that, let me know and I will be happy to answer them. If not, though, you are free to go. I hope you have a great day. Yeah, no chapter 19. I'm going to send you guys a cheat sheet tonight, and I will just include the chapter 19 mechanism just so you guys are able to, like, see it once. But I wouldn't worry about it. It's not on his breakdown, so... Okay, so someone asked, I'm a little concerned about certain questions, like stuff we've never learned or recognized. Do you think there will be a lot of those? No, I don't. So I tried to look for practice problems that we haven't covered before, like in your packet or in SI. So some of them had a few tweaks that like we haven't gone over. I don't think you will have stuff like that on the exam because that wouldn't really be fair, and he's never done that like for any of exam 1, 2, or 3. So I think he will go through and pick questions that either don't have that stuff that you've never seen before, or he'll take that out, if that makes sense. So I'm fairly confident that if you know the stuff we went over this semester, especially all the big concepts, you should be good. So someone also asked, was the final exam review he posted an old video or one for this semester? To be honest, I haven't watched it, but I believe Katrina did, and I think it was new. I think it was for this semester. And so someone asked about chapter 19. So yeah, I'm basically going to send you guys just like the bare minimum, just answer to the reaction that was in our handout, just so you guys have it. And I'm going to send that tonight after the 2 exam reviews, like as a big cheat sheet for the whole semester. Chapter 19 will be there just so I can say that like you guys have seen it once, just so you guys like feel like safe, I guess. But it won't be on there. I'm 99% sure because Dr. West didn't include that in his breakdown. You're very welcome. There's that. I hope you guys have a great day, and I hope to see you later.